For the first experiment, we will need a bottle of water with the cap and also with a hole in the bottom. And we're also gonna need a jar of water, a tray or a glass to prevent water from being wasted or spilled, and also a ruler. First, for this first experiment, we will have to fill approximately 3/4 of the bottle of water and see what happens. As we can see, the water flows faster in the little hole than in this side of the bottle of water. For the second experiment, we will need the same materials, but now in the process we have to replace the bottle cap and wait for some seconds and then watch what happened. As we can see, the water stops like flowing from this little hole, and then we have to remove the cap again. And what happens is that the flow continues. But if you put it again, the flow stops. Now for the third experiment, we're going to do like kind of the same process of the other experiments, but now we have to record the value of the height of the water. The approximately height of the water now is of 6 centimeters, which means that is 0.06 meters. And now we're going to remove the cap again. And we're also going to measure the diameter of the hole.
My personal conclusion is that I think these experiments are really fascinating of how all the data of the gravity, height, area, and the velocity help for understanding the application in real life of the Torricelli theorem, that this focuses on studying a liquid that is inside a container that flows through a hole thanks to the action of gravitational forces. This is how it allows calculating the exit velocity of the fluid through a hole. The volume flow helps us to know the amount of fluid that can be circulate through a pipe unit of time, and this can help us to understand the continuity equation later.
My name is Luis Eduardo Martinez Ramirez. I am from the group number 602. My conclusion of the activity is that I think that it was an interesting group of concepts to check. One of these concepts is a Bernoulli's theorem that explains the behavior of the fluids in a line current and establishes that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. I find that really interesting. Therefore, it means that if the fluid flows horizontally so that no change in gravitational potential energy occurs, then a decrease in fluid pressure is associated with an increase in fluid velocity. That is one of the things that I think were most interesting in this activity or topic, and I'm glad that I got to learn that in these days.
My name is Sofia Molina Padilla, and thanks to the experiments, we were able to understand how each of the theorems work as we practice them by solving problems. In the experiment, we were able to observe how the pressure in the water works and how water comes out of a small hole only if a certain pressure is released. Also, by investigating a little bit more apart from what was taught in class, we could observe examples in daily life, as well as better understand the formulas and their units of measurement. Using Torricelli's theorem, we learned the speed at which the liquid exists, and we were able to calculate as well. It's a large topic, but I think that with this problem and experiments, it becomes easier to understand how this happens around us in some way, and by searching the different formulas, it helps us to solve better the equations and the problems.
Hi, I'm Maximiliano Salazar, from the team of Irving Zamarron and the other members. And during this experiment, I was the video maker. I request to the person Linda in this case that she sent me the video so I can check it and I can make the videos. And also I'm editing all the final video. I'm making the edition, sorry. And I think I found very interesting this topic because it's impressive how can you control the pressure of the atmosphere and everything about that you can do with water. In this case, for example, we had the experiment that we do in this exercise, and yeah, I think it's very important to know things about like that to how can big business or something like that can use that kind of energy. It can be said like that. Yeah, that's my conclusion of the topic. I think it's very interesting and very funny how you can control that. Thank you and see you.
My conclusion about this exercise is that being the team leader, I have to be closely reviewing each of the members and its areas. Part of my role as a team leader was to understand everything we had to do, which helped me to get a general idea of the whole exercise in order to support my colleagues. And an example of this was to have a preparation to support to the experiment maker, where I will observe topics such as output flow, fall velocity and filling, as well as observe phenomena of pressure inside and outside the bottle. It was also necessary to review doubts, but fortunately we had the necessary knowledge and the proper organization to do the work as a team.